Alright, looks like we're recording. Welcome to EECS 494 optional discussion. I'm the GSI for the class. You can call me Ish. This is going to be fairly brief this week, but the idea of these optional discussions, unofficial discussions, is to, have an opportunity to, talk a little bit more about material in the course, some extra material like tips and tricks that might help you out, maybe do some review of lecture content, basically kind of like an alternative version of office hours where we can work as a group and talk about different things. So for today, as an overview, I was going to start off by doing a little bit of lecture review and then go into some tips and tricks with setting up your Unity workflow. That is, when you're working with Unity on your system, what are things that you can do to make it maybe easier to work with and work with others. So to start off, I wanted to talk about colliders and triggers, which is one of the concepts we covered in lecture on Wednesday. So there was the whole little set of slides, but the gist of it is this. When game objects touch each other, the way that the game engine and you, as a result, writing scripts in the game engine, know that these two game objects have interacted is because they both have colliders on them. And when the colliders touch each other in the 3D space, we know that the two objects have collided. And Unity has two different types of colliders, which there are triggers and then there are normal colliders. And the difference between a trigger and a normal collider, in summary, is that a trigger does not have a physical collision. It's just an event that two things are, in contact with each other, while a normal collider is a, physical collision as well. So, the ball on the floor here, that is a physical collision. But in the example of the ball maybe touching a collectible, you can see the collectibles here have the isTrigger property on them. So as a result, these, let me just start here. I just have a roll-a-ball example game here that I'm going to be using for my demo. You can see when I touch the collectibles here, there is no physical collision. They just automatically disappear when I touch them. If I were to go to the collectible, uncheck this isTrigger box, and to demo this, that's not all I have to do. I have to change this to onCollisionEnter in the code. Just to make completely sure, in Unity, there's a separate event in the code you have to write, onCollisionEnter versus onTriggerEnter, when you're dealing with interactions between triggers and colliders. So if I did this right, now all of our guys, script error onCollisionEnter, it's angry at us. Message parameter has to be of type collision. See, there we go. And then collision still has a .gameObject, so we can still do that. Now Unity should be less mad at us. And for those of you watching live, if you have any questions, feel free to stop me at any point. So now that it's a collider, you can see, like in the example we had during lecture, bumping into these balls causes a physical bump in your movement, which isn't the greatest. Oh, all right. So that's sort of a quick overview of the difference between triggers and colliders. The other thing that we went over on lecture on Wednesday that I thought would be useful to go over is coroutines. So coroutines enable you to have fake multi-threading in your game. Unity's scripting engine or scripting pipeline is kind of single-threaded, which means that if you want to do something like wait for 3 seconds in the case of, you know, the Zelda transition that we talked about in class, you would use a coroutine to achieve that. Another example of using a coroutine is, let's say, every minute or something like that, or every 20 seconds, you want to check if something is true within the game world. There are multiple ways to do that. One of them would be to, like in your update function or fixed update function, be checking a, you know, like incrementing a time variable using time.deltaTime, and, you know, checking when that reaches your threshold for the interval you're checking. So you can do like a for loop in your, or I mean, you can basically use the for loop that's implicit in the game. So remember that the game engine runs at, you know, essentially within a loop that happens every, you know, fractions of a second, and implicitly all the code you write is going to be running within that loop. So like I mentioned, you could just use the variable time.deltaTime. So if I were in, say, void update, let's say, oh man, it's trying to autocomplete for me. That's frustrating. Sorry about that. Let's say I had a private float time. What I could do here is time plus equals time.deltaTime, and then if time is greater than or equal to, say, 2.0, let's say we wanted to print something out every 2 seconds. Then we say time is equal to 0.0, debug.log, 2 seconds have passed. So let's run this and see what happens if I do that. And is everything okay so far for you? Hopefully everything is coming through and you can see it all. Okay, so let me get to the console here. I'm going to hit play on our game. So if I did this right, what we should see is every 2 seconds we see 2 seconds have passed being printed out on the screen. So that's okay, and that's a perfectly good way of doing this. But another way to go about doing this would be to use a coroutine. So an example of that would be coroutines are, like I said, they're functions that essentially run on their own like fake thread of execution. You can think of them as essentially threading for the purposes of this class. So you can run them each, and they each run in their own kind of field of execution, their own context, if you will. So if we wanted to do what we did here, where every 2 seconds we do this, hold on, there's the yep, let me show you what that might look like if we were to write a to start off, IEnumerator is the return type of a coroutine, and that's because in the underlying C#, we're using a special type of function. IEnumerator print every 2 seconds. And then we'll start writing it. Right, I think it's yelling at us because we want to use system.collections. You need to import that. Now we need to, what I'm going to do is essentially while true, I'm going to make this infinite loop essentially. But remember that if you're writing loops in coroutines like we talked about on Wednesday, we're going to have a yield return null at the end of our thing. So at the start, though, we're going to have a yield return wait for seconds 2.0f, which basically means wait for 2 seconds. It's new wait for seconds. Sorry about that. And then we'll do debug.log 2 seconds have passed. And then the last thing we want to do, let me comment this out, is in our start. Start is the function that runs once at the beginning of the game. We're going to say start coroutine update. Or not update. That would be bad if we called update on start coroutine. Print every 2 seconds. So we will do that, and let's see if that works. So now you can see at the same behavior as before, 2 seconds have passed. But maybe this is a little bit easier for us to understand what's going on. We basically created someone else to do this for us, because before in our update, you can imagine that in maybe a bigger game project, your update function is full of a lot of things going on, and having to keep track of your own time variable, increment it using time.delta time, check if it reaches that, and resetting the variable. That might not be the most convenient thing for you to have to do. Instead, we create someone else, basically like a coroutine, as they're called, and we say, hey, you do this for us, just print every 2 seconds.
Hey, Ish.
Yep.
Can you explain really quickly what yield return null does?
Yeah, sure. So remember that the Unity scripting is not actually multi-threaded. It is running in one single thread, and that means there is, like, where the Unity engine, it runs so many times per second. There's a lot of Unity code that needs to run, like it needs to update internal values, it needs to actually render stuff to the screen, it needs to, calculate all these things. If we didn't say yield return null, if you've taken 482, this is the same idea as a thread yield. We're just saying, hey, our coroutine is just ending this iteration of the loop, so we want everything in the Unity game engine to finish this iteration of the loop as well, and then you can come back to us. So in the in-between this call and this call up here, things will have changed. So let's actually look at this. I'm going to say debug.log time.delta time. So what I'll do is I'm going to remove this call as well. So I'm going to have a yield return null here, and I'm going to be logging the current time in my coroutine. So let's look at what that looks like. And then I'm going to remove the yield return null, and then we'll look at what that looks like as well.
Okay.
We're going to get flooded with a lot of print statements, I imagine. Yep, you can see. It's a bunch of different values because delta time refers to the time between the last update and the current update. So you can see that this value is changing, meaning that the engine is constantly running and updating. If I were to comment out this yield return null, what we expect to see is the same value being printed, and that's because, and we're also going to expect to see the game kind of freeze up here. So if you saw before, the game wasn't freezing, we still saw our little floaty collectibles, rotating around like they normally do. Give it a little bit. It's thinking very hard.
So with that coroutine, as you initially had it written, would it, it wouldn't take exactly 2 seconds between printing. It's 2 seconds for that first yield return plus whatever happens when you yield return null, whatever work has to be done there. So it'll be a little bit more than 2 seconds.
Yep, it'll be approximately 2 seconds essentially.
Okay. Yeah.
And the player isn't going to notice the difference between an extra frame.
Right.
Wow. I don't think Unity wants to play for us. I don't think it likes what we did.
That's fine.
But I can't get it to cancel at this point, so. Basically, you can imagine that it would be as if time froze if we didn't have that yield return null there. And that's not good because then the rest of your game freezes up, and then you don't have a game anymore, which is not what you want when you're in a game development class. We'll just let this guy wait. So there are that was what I wanted to go through from lecture review. Now I wanted to go over some short sets of tips and tricks for the Unity editor, not too many. A lot of what you might want to see can be found online. Gosh, I might have to force quit the Unity editor and restart it here. It's unfortunate. Huh, it's not even showing up here. Oh, there it is. So let me restart the Unity editor. So one thing that you may not have had a chance to do during the first tutorial, or maybe not even with the second tutorial, is to take a look at all of the different windows and options that are on the Unity editor. I'd recommend taking the time at some point, if you have some free time, to look at the options, try different things out. I currently, since the beginning of the semester, I've had the Unity editor kind of in its default configuration, which isn't actually how I like to use it, because I was saving up basically for this discussion, where I'm gonna take it from the default view and then show you how I like to keep the editor when I'm working. the first things first, actually, I have this up here already. Let me close that. Hold on. So one thing that I like, there's the lighting window here. If you ever want to mess around with the lighting, there are so many different settings here that you can try messing with. If you wanted to change the skybox, that's in here as well. You know, in this example here, I took a bunch of pictures of the Duderstadt Center back in 2019, and I made a skybox material out of it. I can drag that in here, and now it's as if the game is in the Duderstadt Center. If that's what you wanted, you could do that. Let me set it back to the default skybox. So I like to keep the lighting tab right next to the inspector. Reminder that you can find all these different things here. Next things next, I like to keep the animator and the animation window down here. These are super useful to have access to, especially for P1, when you'll be doing all of the 2D animations from the sprites we give you for Zelda or Metroid. You know, there's the audio mixer, which you can work with. The profiler is also nice to keep here. The profiler, what it does is, if you remember perf from 281, it's kind of like that, and it essentially lets you look at what all of the different things are, what your performance bottlenecks might be in your game. You know, if there's anything that's using too much memory. We'll go over this at some point in lecture with a little more detail, but just so you know, that is one thing available to you. But I guess the main difference that I sort of do compared to the default view that you guys might find useful is to keep both the game and the scene view up at the same time. I usually make my inspector a little bit smaller and my hierarchy a little bit smaller, and then have both of these here. When you do this, you'll see something like this, and that's because the game view will be set to free aspect. I usually set the game to be 16:9 because that's generally what people are going to see when they are using the game, assuming that they're on a 16:9 display. So, you know, there are all sorts of different things. Some people like to, you know, put the game view really small in the bottom right corner. If that works for you, you can do that. Some people like to move the hierarchy to the right and the inspector to the left because it makes more sense to them. Some people like to keep the project view here next to the hierarchy. But what's worth knowing is that in the Unity editor you can rearrange anything to your liking. And I encourage you to look at that and try it out and see if there's something that maybe makes you move a little bit faster when you're doing your development. At other discussions, I'll definitely go over other small tips and tricks. This is just kind of the big main one I wanted to go over as you get started, is to just experiment around and see what works for you. The next thing I wanted to go over is two really useful keyboard shortcuts in the Unity editor that you might want to use. The first one is F. So you can, in the hierarchy on the left here, you can pick any game object, and then if you hit just the F key, no other modifiers on the key, just F, while you have here, essentially what this will do is hitting F will take you to the game object that you have highlighted. So let's say you have a super huge game and you're like, oh, where did the player go? You can click on the player here and click F, and it'll take you over to the player, and you can see where it is. You're like, oh, where is the camera actually? I'll hit F and I can see where the camera is. So that's pretty It's very, very convenient. Your mouse pointer needs to be inside the scene view when you click F. If I click F while my mouse is out here, it won't work. If I click F when my mouse is over here, it won't work. But if I click F while my mouse is in the scene view and I have an object selected from the hierarchy, the letter F will take me to that object.
Yep. Could I interrupt you real quick?
Yeah.
How were you just jumping between like the move and the little hand thing, like in the very top left? You were just jumping between those really quick.
Yeah.
Do you know what I'm
Yep.
saying?
When you see the little hand thing right here, I'm clicking the middle mouse scroll wheel on my mouse, and I'm moving the mouse.
Oh. Okay.
So when you click on the middle mouse button and move the mouse, then you can drag like this. If you right click in the scene view, you can look around. If you left click is for modifying game objects, and scrolling in and out will zoom you. So if you want to be moving around the scene view without using the arrow keys, you can also use the arrow keys to like move left and right, as you might know. If you want to just be zooming in and out, you can click with the middle mouse key and drag to move the scene. Sorry, that's a good question. I should have mentioned that. See, now I zoomed all the way out and I'm somewhere over here, but I can hit F and it takes me all the way back in. And it's a good way if you get lost in your scene view to go back to where you were before. The other keyboard shortcut I wanted to go over is ctrl+shift+f. And what that is let me sneak this to you here. Ctrl+shift+f is called align with view. So what that means is any object you have, it'll align its rotation to however you're looking in the scene. Now, where this is useful is mainly for the camera. So if you look in the game view right now, the camera is kind of at an angle. I did that on purpose. Let's say I wanted to make the camera a straight behind view. So what I can do is I can make the scene view look like a straight behind view. Like I can make the scene view be like, hey, this is what I want the camera to be at when I play the game. So maybe I want it to look down a little bit more. And I can adjust the scene view to be like what I want my camera to be. Sorry about that. And then what I can do is I can go to game object and I can hit align with view, or I can hit ctrl+shift+f, and you can see that the camera for the game is now aligned with what I was looking at in the scene view. So if I were to zoom out and hit ctrl+shift+f, now it's completely zoomed out, just like it was here. And this can be really useful, much more useful than messing around with dragging these values and rotating it manually, or even using the arrow keys here to align it to where you want it to be. This is great for a little bit more fine-tuned control, but if you want to like move the camera very quickly to where you are, moving your scene view to where you want to be, which can be pretty fast, highlighting the main camera and then hitting ctrl+shift+f is a really quick and simple way to do it. It's also a good way to say, set the spawn point of the player. So let's say I wanted the player to actually spawn closer to here. I can highlight the player and hit ctrl+shift+f, and now the player is going to be spawning where I was. If I come down here, let's say I want to start the player over here, I can do the same thing with the player, and now the player starts over here. So those were the kind of two tips I wanted to go over this week. I'll definitely try to come up with some tips for the Unity editor to go over every week. So hopefully that's a nice addition to this discussion. I'm about wrapped up. There's one last thing I wanted to mention. There's this YouTube channel called Brackeys. You may or may not have heard of. Brackeys makes a lot of awesome videos about Unity. So if you're, let's say you're trying to design a menu in Unity, there's a great YouTube tutorial here to try and get you some guidelines on how to design that. There's stuff with shader graph if you wanted to mess with the shaders in Unity. There are a lot of useful videos here that might be useful to learn about Unity and, try to improve your kind of tool set of things you can achieve in Unity. So I would recommend checking the YouTube channel out if you're interested. That's all I had for the discussion today. We're done a few minutes early. If you guys have any questions, feel free to let me know. And yeah, thanks a bunch.
Thanks, Ish.